I'm now going to give it to our president, Mr. Enzo DeStefano.
Actually, it's going to well, no, I'll keep it. Okay, so welcome everybody to spring semester of RITSec. It's good to see all the faces again, and I'm glad that we can still meet in person. Fingers crossed for the rest of the semester. So, obviously, number one thing, please sign in if you want to be counted as a member. Scan this QR code. You got to sign in. And in the case that we have pizza, not this week or next week, probably because of COVID. You have to sign in to get pizza. So, or you could type in the link. Yeah. So we're going to do a bit of e-board introductions again because we see some new faces around, and we figure we'll do this again. It'll be a bit quicker than last time. I know we spent a long time in the beginning of the semester. So if you don't know me, I'm Enzo. I'm the president of RITSec. I'm from Rochester originally. I'm in my last semester of CSEC, so this is my last one. So graduating, I'm going to MITRE over in Nova with every other RIT grad in existence. I do Windows Offensive Security, and I'm always learning. So if you have any questions for me, just always feel free to hit me up on Discord. I'll try and answer as quickly as I can. So.
Hello, everyone. Oh, geez. All right. Hello, everyone. I'm Brad. I think I've met a lot of you just in and out of the club room this week. It's really great to see everyone here. But I am the PR director for RITSec. I'm a second/third/whatever year. I am semi-co-oping with the cyber range, doing work with CPTC and stuff like that. Also, people know me as the web guy. I love CTFs, all this kind of stuff. Red team, black team, blue team. Talk to me about it all. I want to get to know you guys.
Hi, I'm Jasmine. I'm the secretary for RITSec. I'm a second-year CSEC student and a psychology minor. I am the logging lead this year for ISTS. I will be co-oping this summer with Deloitte in Seattle. I'm a member of WESES. I'm from Maryland, and I love cats. So if anybody wants to discuss about cats, I'm your person to go to.
Hey, I'm Philo. I'm the ops lead, so I'm responsible for our mess of servers that are to run our competitions and research.
Wait, no, I wasn't trying to interrupt. I was trying to clap for doing that because that's fucking impressive. So please continue. Wait, what? Are you good?
Yeah.
Sorry.
I didn't really have.
Hi, I'm Allison. I actually wasn't here last semester, so this is my first semester back in a while. But I am the ISTS CA, which is going to be held this March. I'm a third-year CSEC BSMS student and a CS minor. I was at Security Risk Advisors. I'm now hopping onto the MITRE train for this summer. I was the ex-Black Team logging lead, and I do malware station at the Blue Team Village. Come check us out. But yeah, certified cat lady too. So. Woo.
Hello, my name is Jason. As I said, I'm the CA, also the unofficial hype man of RITSec. Yeah, I do black team, red team, CCDC, just generally goofing around all the time. My goons in the back over there, we got Nolan and Jake, give them a shout out for also being goons. And I got one more question. Is this anybody's first time coming to club? Can we give them a big round of applause? This is fantastic. Yeah, I just want to welcome you guys. Welcome to the community. We got a lot to do, a lot of fun stuff that you guys can help out and do. So welcome and enjoy the experience. Yeah. The slide didn't change, but
it didn't change.
It did not.
Zoom on. Oh shit, it's on. Well, it's supposed to.
Okay, we're gonna stop share. Yeah. And we're gonna start share.
Zoom. Let's go. Hold on. There it is.
Oh yeah, there we go. So I am just realizing that I forgot to completely do this. So this is the same as last semester, which some of this is wrong now. Third year now, still math minor. BSMS is confirmed. I'm a crackhead and love overloads. I'm taking 22 credits this semester. Mainly do Arch now. Kind of dropped Mac. Yes, I have interned there. That didn't change. I'm going to IBM X-Force Red for pen testing this summer. That's new. Yes, still only picture I have of me. No longer e-board in my fraternity. Mechanical keyboards, big junkie. I was just trying to, last night, get some buddies to use a 40%. So if you know how terrible that is, yeah, hate me, please. And yeah, all that information. Yeah, that's all.
Hello, my name's Braden. I'm the head of education. Yes, we're feasting at Gracie's as the classic. I am for DMV native, aka like Delaware, Maryland, Virginia, DIC, Maryland, Virginia. Damn, I don't even know where I'm from. I'm a third year CSEC, BS. I co-opted at SRA last summer, all the way summer and spring, and this summer I'm going to MITRE along with everyone else. Yep. I do a lot of Linux stuff. I did that for Black Team for IRSec. I do Red Team stuff. I do it for CCDC. So yeah, but I don't daily drive it because why would I? don't know. I'm weird. And I also do a lot of radio. I'm trying to get into that. Yeah, that's pretty much it.
Hello, everyone. My name is Tenchi, and I'm the head of research.
Yeah.
Thanks. All right. So I'm from Las Vegas. I don't know how I got here. Yeah, I come from the desert. It's snowing outside. I've never seen that before. So I'm a BS in CSEG with a minor in math. Yes, I know. Yes. And I'm also the team Contagion captain. So if you're interested in competing at CTFs, hit me up. Big Windows guy. I love Windows. I mainly work with Windows. Finally, I daily drive Windows. I used to use Mac like a loser. As I have an Apple Watch in my wrist. Yeah, you know. Okay. Yeah. Okay. Yeah. I was a big blue teamer, ex-blue teamer, right? And then this summer I'll be co-oping at SRA with the Red Team. And yeah.
Okay, Olivia's not here right now, but she wanted me to say 3 things. FOSS, Linux, and she loves glitter. So that's Olivia. She actually said that to me.
All right. We are now back to the normal RITSec, normal scheduled program. Can we, yeah. Should we? Oh, yeah, next slide. So, first off, Megan, the wonderful Megan in our department is leaving. She helped us, the club and the department so much. So if you haven't had the chance already, please sign this poster. We are doing a send off for her. So we want all the club members to sign it. She is amazing, and it's so sad to see her go, but you know, we want to make her send off good. Should I wait? I'm gonna wait so people can sign it. This should only be like a couple minutes. Yeah. Put the music back. Hold it. What? Oh yeah, and we will have a thing at 3 p.m. today for Megan, like a send-off ceremony. So stick around for that, of course. Is that after the research section? Yep. Okay. I know you are. I'm not gonna steal your thunder. I guess we'll put the music back on. Sorry, stream, I can't let you hear it because it's copyrighted. All right, that was a very short intermission, but we're back with the announcements. Thank you for everyone to come up and sign that. All right, please join our Discord. Especially if you are new here, you have not heard this yet. Our Discord is where we communicate. We do everything. We announce everything. It's the place to be if you want to stay in touch with the club. So you can join it by going to discord.rtsec.club. There's a QR code, and there will be a verification process. If you have any issues, just reach out to the bot will DM you and reach out to whoever. Do what it says, and we'll help you out. And you'll get access to the rest of the server. So yeah, make sure you check that out. We have a calendar, calendar.retsec.club. This is where you can see all our upcoming events, including meetings, interest groups, any special events, stuff like that. So another way to keep up to date, add the calendar, look at the calendar, use it. We have a mailing list. We send a newsletter out every Wednesday night, maybe Thursday morning, mail.retsec.club. That will have all the information for that week that you need, including who's presenting, what education topic it is, what events are coming up, where you can sign up, all the fun stuff. Newsletter is great. Check it out every week, mail.retsec.club. And then we have an anonymous feedback form. If there's something you think can be changed, something you like, don't like, whatever you want to say, there's an anonymous feedback form where you can say what you want. We will look at it, we will read it, we will discuss it. So check out that form if you feel the need. All right. We have gotten our swag. If you have not picked up swag or have not paid for swag or something like that, come pick it up, come pay for it, come get your swag. It's right here. Enzo's at the front of the room. Are you doing it live? During it? Okay, we're doing it during demo time. And if you don't get it today, you can come to the club room and pick it up pretty much during the entire week. Yeah. Find an e-board member to do that. Don't just ask somebody random. They can't help you. All right. UB Lockdown, if you competed at UB Lockdown and you placed and you got a prize, the prizes are in the club room. So go to the club room, ask for an e-board member, and we'll help get you your prize. Yes, get your stuff. You won. Why wouldn't you want it? All right. Important announcement.
All right, blue team and white team signups for ISTS are now open once I finish making this announcement. So please sign up. As a reminder, ISTS is an advanced purple team competition that we host every year. This year it's going to be from March 4th through 6th. We're hoping to gun for in person, so look forward to that. But yeah, super excited. Yes, Brad.
What's a white team member?
A white team member is the white team is the people who help support the competition. So these are the people who are physically setting up the room, grading injects, watching team members, making sure that everything's going smoothly in order to operate the competition when it's happening. Yep. Yep, so 5 people per team. This year we are letting in 3 teams from RIT. 1 team is reserved for the winners of IRSec. So the other 2 teams will be chosen randomly from the pool when signups close at the end of the month.
Refresh the slides? Bro.
Bro.
Bro. Bro. No, I gotta refresh the slides, don't you? Nothing changed. The next one?
All right. Okay. In any case, please message me on Discord if you have any questions.
Thank you. I think Jason might have an announcement after telling me to refresh the slides, and a new slide just randomly appeared.
Exactly. All right, hello. So among running IRSec, I also run the CTF, which is going to be happening in April. So now it's the time of the year where we gear up for the CTF. So if you guys have some ideas for challenges and you want to be a challenge author, fill out that form, and we'll be having some challenge hack nights where we can kind of brainstorm some ideas, implement some challenges, and just have a good time on the Thursdays of February and January, specifically 120 and 210. Those are kind of convenient dates. I like it. Nice and orderly. Yeah, so fill out the QR code. Yes, Brad? Do I have to have a challenge idea if I want to help? No, you do not. I am coming up with a list of ideas, so if you just want to write a challenge but you don't know where to start, come to these hack nights. We'll get you set up, get you some brainstorms, and it'll be fantastic. Question?
Are black team junior and white team mutually exclusive?
Kind of, sort of.
In other words, are we going to be doing things with black team junior that things in the decks that would prevent us
Yeah, follow up with Allison and other people later. Solid question, though. Yeah. Next slide.
Next slide.
Yes.
There's another one.
Yeah. So, coming back from an old tradition that we used to have. Hackathon is a thing where we are going to gather in the labs and we're going to do a bunch of hacking for 12 hours instead of 24. And we're going to have some food, and it's going to be maybe food depending on RIT. But we're just going to chill in the labs, have a great time on a Saturday in February, the 5th. So save the date and come join us in the labs and have a great time at Hackathon. We'll have some presentations, learn about some coding stuff, and just enjoy the experience. Yeah.
All right, that's all for Jason's announcements. Let's move on. So, oh god, here at RITSec we have a bunch of different interest groups and interest programs. They're listed here. So we have incident response, RVAP, reverse engineering, physical security, team contagion, WESIS, and red team recruiting. If any of those sound interesting to you or you want to know more about them, please ask for these people, reach out to these people. You'll see them on Discord. If you ask an e-board member, we will also point you to the correct person. If you want to know when they meet, it's on the calendar. Yes, Tenchi? Can you make a specific announcement about Contagion? Sure, yeah.
So I think I briefly mentioned this a little earlier in my introduction. So Team Contagion is the CTF team under RITSec. We're the academic team. So we'll be meeting every Wednesday from 6:30 to 7:30 in the air gap. We will be doing some fun presentations as well as hack nights on a weekly rotation. So I highly recommend you. Also, we're going to have some cyber start sessions. If you guys know about that, it's a very beginner-focused CTF that we do. So if you're looking to get some help and you want to kind of do it in a community setting, please come to Team Contagion in the air gap. So it's going to be the GCI second floor, 2750. All right, that's it.
Thank you, Tenchi. All right, but yeah, I mean, the other ones, I'll give a brief overview. The other ones, incident response is about incident response, so blue teaming incident response. RVAP is penetration testing, essentially. So I don't know the acronym for that, actually, but it's penetration testing, red teaming stuff. Reverse engineering is reverse engineering, usually malware, stuff like that. Physical security, self-explanatory. Tenchi just explained Team Contagion. WESIS is our RAT Women in Cybersecurity chapter. It is all-inclusive, so anyone can go. You do not have to be identified as female to go. So show up to that. And then Red Team, talk to Emmanuel about that. That's for Red Team Air competitions. You do have to get on the team for that one. But if you work towards it, you can definitely get on the team. You don't need any prerequisites or anything. All right. Here is basically an outlook, general outlook for our upcoming semester. We have the hackathon that Jason talked about. We have an RITSec career fair eve, which is basically you have the career fair where we have our own career fair right before. That includes all of the sponsors that have decided to show up, and you can talk to them individually. It's a much smaller career fair. You know, you don't have all of RIT there. It's only RITSec, and it's only for club members. So check that out when it comes up. We'll post more information. ISTS, the competition that Allison just talked about. ShmooCon was moved. That is a security conference that we go to every year as a group, kind of just as a group. It's not really an official event, but we show up to ShmooCon. And then RIT6 CTF that Jason also talked about. That's our yearly CTF. So, yep, that's an outlook of the schedule for this semester. Let's clap it up for our sponsors. They help us get everything done. One more. All right. Yep. Okay. We love our sponsors. They help us do everything that we want to do and would like to do. So we love them. We have social media, and we now have someone running it. So there's actually stuff being posted. So So actually check out our social media for real this time. There's good stuff being posted on there, pictures, updates, pretty much everything. So yeah. All right, I think that is it. And without further ado, after that very long intro, clap it up for Michael Vaughan with Advanced Linux.
I am good until when?
115 is the hard, okay, that's a little too far, but shoot for around one.
Yeah.
Take out how long these go.
We'll be all right. Okay, can everybody hear me all right? All right, so we're going to be talking about so-called advanced Linux today. My name is Michael. I am a fourth year in the BSMS program here, which means that I've been here for a while, and I will be here for a little while longer. I'm on the red team. I don't consider myself an expert, but I've been using Linux in like a personal or professional or some sort of capacity for about 7 years. I'm the treasurer at the Linux Users Group, which is another awesome club here at RIT. And you can find me at any of those links. All right, so we have actually quite a bit to cover today. We're going to do some review. We're going to go into some more depth. Unfortunately, I really think that this presentation format, you just can't get everything that you want to talk about in Linux. So we're going to focus on the important stuff, what you should know, and especially on things that I don't think are as well documented, but that are necessary. All right, so some basic permissions overview. Many of you have done Linux stuff before and you'll recognize this, but when you have files, resources in general in Linux, they have 3 basic permissions. Those are read, write, and execute. And those correspond to numbers, so 4, 2, and 1 specifically and respectively. So the idea is that every file has a user that owns it, a group owner, and then permissions for everybody else. And then you add these numbers together. So if you want to have, like in the bottom right corner here, and middle corner or middle box, 644 is like read write for the user. 4 plus 2 is 6. 4 is read for the group, and then 4 again for everybody else. And this is called octal syntax. You'll find that online. You can also use change mod with like a letter instead. And there's also the SUID bit, which we'll be talking about as well. All of this falls into what we call discretionary access control. What that means basically is that the permissions are at your discretion. You can set the permissions. It's up to the users to set them correctly, and you have the freedom to do that. And some access control systems do not have that freedom. There's benefits and downsides, but when people talk about discretionary access control, it means it's at your discretion. You get to choose. There's a couple other things you should know about with permissions on Linux. We have this concept of extended attributes. You can see these with ls attr and change attr. And these are basically just additional flags on a given file. So you can make a file, let's say append only, or a fun one is immutable. Like you might have write access to that file, but if it's marked as immutable in the extended attributes, then you'll get a permission denied every time. So these are additional flags that you can basically set on a file. They're all well defined, and there are about, I think I want to say 10 or so of them. The important thing, though, is that they're really only supported on certain file systems. The good news is that most file systems you'll see will have these, but if you're using like FAT32, like thumb drives or something, these might not actually be respected on that disk. The previous slide mentioned, too, this idea of the setuid bit. Normally, when you run a program in Linux, it runs as your user. So if I run ls, it'll run as my user to see my files. But if you would like to, you can set the SUID bit, which basically means run this user or run this program as the user that owns it. So not as me, but as the user that owns it. Most of the time, that's root. And the idea basically is some files, some programs need to run as another user. So if you imagine you want to change your password, everybody should have the ability to change their password, right? But actually setting the password hash requires root access. So you'll run setuid on the password binary, and that way it'll have access to actually write to that root-owned file. But anyone can still run it, so they can still change their password. There's a couple of examples of this, and setgid is run as the group owner. It's the same thing, but for the group. Every user has a UID, and there are 3 kinds in Linux. The first 2 are pretty well known. It's the standard, which is like a number that is for your user, hopefully unique. And then there's also this concept of the effective user ID, which is basically the user ID that you're actually currently using. And the reason why we just have a distinction between the 2 is because sometimes a program will want to run as another user temporarily. It might escalate privileges or de-escalate privileges. And the way that that's implemented is through what we call the saved UID. That's basically where the old one is stored so that you can drop to or recover from it later. The saved UID is not as well known, but there are some interesting CVEs that have come out as a result of it. It is something I think that's good to know. Whenever you're dealing with your permissions, you really want to keep a strong eye on them when you're securing a Linux system. There's a great utility on most systems called find, and that will let you very quickly recursively search for files based on permissions or other criteria. In this case, we're looking for files in the root directory owned by the root user with the SUID 4000 or the SGID permission set. So this will help you find all of those binaries on the system. You, in general, want to follow what we call least privilege. You might have heard of this in your 101 or 141 class, and that's basically that you don't want to run everything as root. In general, when you're dealing with permissions on any operating system, getting to know what's okay, what's fine, and what isn't is just something that you're going to get with a lot of repetition. So the best way I would say is to just poke around your VM, maybe in demo time, on your own time, and get familiar kind of with some of these common programs and processes so that you can have an eye for what's okay and what isn't. We mentioned users. All users have a username, home directory, UID, and a shell. They belong to groups. So you might have, in many cases, let's say the Oracle user might have an equivalently named Oracle group, but it might be a part of other groups like student or admin or wheel. You want to check for users with a UID of greater than 1,000, also for UIDs of 0, because that's roots. If you have 2 of those, that's probably an issue. And you also want to make sure that the shell kind of makes sense. There are some system users that are used to start services, so like Apache 2. There's a games user. If the games user has UID of root and a bash shell, that's probably not legit. So something that you should think about when you're looking through your passwd file, which is what you see on the image below here. Just some basic review on the file system. I'm not going to go through all of these, but there's many different subdirectories under root that sort of categorize what you'll see on a system. The ones that are bolded and indented are temporary virtual file systems. So temp is for just scratch space. It's world writable, so you'll see a lot of malware try and write here because it has access most of the time. And a running process is also going to show up under the proc directory. You'll see all sorts of different things about running processes in the current state of the system. And if you want to look more at like device and driver-specific information, you'll find that under sys as well. Other important directories, etc for your system-wide configuration files, and the var directory for variable content, your logs, and stuff like that. You might have heard this adage when you're working with any sort of Unix-based system that everything is a file. And it's a very common catchphrase, and it is mostly true. Almost everything is exposed as some kind of file on your disk or just virtually by the kernel. And generally speaking, the way that your common utilities work is that they will read from these specific directories to get information about the system. So PS will read process entries from proc, route will read from procnet route, ARP is from the ARP directory under procnet, and then uptime and pretty much everything else you can think of is in some way reading from proc or sys or something like that. The kernel exposes a lot of information about the running system, and that's generally how people read it, is just by opening those respective files. So for an example, this is kind of what the proc directory looks like on a given system. In the top, we have basically running ls on the proc directory. You can see on the left side, there's 1, 10, and 11 subdirectories, and those are process IDs. 1 is the first process, the init process. Because I'm in a container, that's actually bash. But then there's 10 and 11, which are some other processes that are running inside this system. So if you look here on the bottom here, we can run PS, and it will read all of this from proc for you and display it in a more readable format. And if you actually go into we'll see here there's bash, there's a sleep process running, and PS will actually see itself as well. And if you go under PID 10 and look at what's inside here, there's a bunch of files that will tell you about that process. A big one is command line, which will tell you basically the arguments that are running here. It does it without spaces, so it's actually all the way on the left here. Sleep inf is basically an infinite sleep. And an interesting thing too is you can actually see the executable that's running under proc PID exe. And the idea there is that if you want to see exactly what program is running, it'll point to it. And the nice thing too is that this will also work if that program has been deleted from the disk. So because it's holding that file handle open, you can still actually cat it to a file and see that. A lot of malware authors will deploy that and then delete their binary, but you can read it this way. So yeah, these important paths. Another one is the environ file. This will tell you your process environment variables. And this is really, really relevant when you're talking about a lot of exploits out there, especially when it comes to like web and stuff like that. You have like local file inclusion, that kind of thing, and you see proc environ in your logs. That means that somebody is trying to dump your environment variables for that process. And in a lot of production applications, there are very sensitive variables, API keys, things like that in there. So it is a very important file to look at. You can even open and cat to or write to the file descriptors for an open process, which is kind of neat. You can get an idea of the memory maps, which will tell you where things are located inside a process's like memory. So you might see libraries or additional segments within that file. And Linux has this idea of process limits, where you can set system-wide limits on processes. And if you want to see how those limits are affecting a running process, you can see that under here as well. The way that the file system works, and just in general with hard drives, is you're going to mount them somewhere. In Windows, it does this automatically for you for the most part. But on Linux, there are automatic mounts under etc fs tab. And basically, you can run the mount command to observe what's currently mounted on your system. And so this is like a high-level overview. When you run the command, you get pretty much everything. Important ones here are the ones on top. You have proc, sys, and dev. These are all the virtual ones here. And then there are some additional, I'm running in Docker, so there's some Docker ones. And additionally, some specific partitions that are loaded for like booting and stuff like that. So all of your mounts are going to be in here. A big thing you want to watch when you're working with Linux are your timestamps. This is really, really important if you're doing anything forensics related, DFIR, whatever, blue teaming. They are going to tell you when files on the system have been edited or viewed in any way. The access time basically tells you just when it was read. You can see when it was modified with M time. And then C time tells you when any detail basically about the file is changed. So if you change just the metadata, C time will change, but A time will not. The other thing about C time that makes it very relevant is that it's substantially harder to fake. You can change the A time and the M time with touch in user space, but to change C time, you basically have to do stuff in kernel, and it gets a little bit more hairy. So most of the time, that's one of the more reliable sources of information. Just be aware that it will change very frequently, including if the metadata file name even changes. So as an example of what you can do, we know that PS reads from proc. We can do an interesting thing where we bind mount a directory over a process entry. And if you do that, then you actually will not see that process in your list anymore. So for an example, we can see here I've started another sleep process. It's running on PID 72012. And if you run PS here, number 1 here, we can see that it's running, and we can see that just fine. But if we mount, basically remount, that's a bind mount is remounting a directory over another one. It'll put a tempfs right on top of that process entry. And the important thing to know about Linux is that if you do that, the system will only see what's on top and not the directory underneath. So if we were to check our PS output again, that's step number 2, we can see that sleep is no longer there. But the interesting thing, of course, is that you will see it under your mount output now. So I just piped that into tail to get the last line. And we can see here tempfs on proc. That's usually not legit, so especially when it's under a specific process ID. And if we unmount that, we can see the process come back magically. Whenever you're working with a Linux system, you're probably going to be dealing with services. These are just normal programs that are auto-run and have some additional features to keep track of logs and status and all that. Usually these programs are going to be what we call daemons, which means they run in the background. So SSHD is a good example of that. The D is for daemon, Apache 2 as well. Pretty much any service that you're hosting on a port that you're keeping up for some client or whatever is going to be running as a daemon. And the idea with a service is that you basically take the output from that program and you centralize it into a single point of truth. And then usually there's some kind of auto running on boot as well. So for an actual service file, these are all defined, or at least they should exist under etc system. In many cases, a automatically installed service is actually going to symlink from user lib. And basically what a symlink is it's just a link to another file. So we're essentially placing that underneath the etc system directory for it to be read by systemd. A service is a really simple file. There's some metadata. You can see here, this is actually the one for SSH. There's a couple of different targets here. We want to start after the network comes up, which kind of makes sense, right? We're running a network service. That's a very common line that you'll see in these service descriptions. And we want, but we don't necessarily need the gen keys service to be up when we start. Perhaps the most important part is what's actually getting started. Exec start is the command that gets executed to actually bring up SSH. And we're just starting the SSHD binary, and this flag right here starts it as a daemon. And there's a neat feature as well. Sometimes a lot of programs you want to reload the program configuration without shutting it down. This is very useful for SSH, right? If you want to change the config file, you don't necessarily want to kick out somebody who's logged in. And so exec reload will basically send a specific signal that SSH will take to mean, okay, I need to reload my config file. And restart always just means that we're going to try and, if this dies for whatever reason, we're going to restart it immediately. If you want to learn more about how to write these, you can go to man7 systemd.directives. That will tell you what some of these words mean. It'll actually link to other man pages. If you've ever seen like Linux concept and then parentheses and 5 or whatever, or 1 or 8, that just tells you what manual section you have to look under. So if I wrote systemd directives 7 in parentheses, that means I open it with man7 systemd directives. You also want to keep track of your sockets and anything that's running on a network. This is basically the bread and butter, right? So if you want to see what's running on your system, the default way to do it these days is with a program called SS, and that lets you see your sockets. A really interesting feature about SS is that you can pass the P flag, and you can see it basically ties a connection to a process name. If you run that as root, then you can see that for all the ones on the system. This is really, really useful if you see that a port is open that you don't recognize, that you don't want, but you don't know what process it's actually opening that. Additionally, you want to keep track of your addresses, your interfaces, your MAC addresses, and your IP routing table. Occasionally, you'll do DNS lookups with dig. That can give it a host name, and it'll give you records back. On top of the network, you have this idea of a firewall. You've probably heard of it. Firewalls filter traffic. Basically, the way that Linux works is that netfilter exists on top of the network stack, which is basically where TCP and all your networking code is implemented in the kernel. And a firewall will simply filter traffic. Normally, it's allowed. A firewall is, like everything in security, something that's thought of after it's built. And basically, the idea with the basic policy, you're going to want to, most of the time, in almost every good scenario, deny all incoming traffic and allow all outgoing traffic. Does anyone know why?
In case anything got in from the inside, you mitigate like how much can even get out at that point?
Yeah, if you're allowing necessary outgoing traffic, yeah. Most of the attacks, historically, I guess, is we're just going to deny incoming and then selectively allow packets to your services. So if you are running SSH, you should allow SSH and deny the rest, and only allow what you need. We're still following this concept of least privilege. A better scenario, of course, is like you mentioned, allowing only what we need outbound. The reason why is because a lot of attackers will use reverse shells, which are basically just outgoing connections to an attacker machine. So you do want to keep track of what's running. And ideally, in a competition environment, in a secure environment, only be allowing what you need, including outbound. So if you want to only do web browsing, you can allow 443 and 80 and port 53 maybe. So yeah, always apply firewall rules carefully. I highly recommend having like a local root shell when you do these. Even if it's a cloud host, you might be able to get in through some TTY somehow. Always do this. You can lock yourself out pretty easily when you're doing firewall rules. And the way that you configure your net filter tables in the kernel is by using the iptables command in user space. So when a packet reaches the network stack, basically you're performing some kind of action based on criteria you define. And usually those actions you're allowing a packet through, or you'll just drop it, which basically means you'll ignore it. Iptables, the way it works is you have rules. Rules are in rule chains, and then chains are in tables. So the default table is what we call filter. If you don't specify it, this is what your rules will get added to. There's also a NAT table for specific NAT changes, if you have to change an IP or something like that. The mangle table is used less often, but it's called that because ideally you'll put your rules that actually change packets inside the mangle table, assuming they're not in NAT already. And then there is a security table, but this is in reference to mandatory access control utilities like SE Linux. They will put their firewall rules there. There's this language of like dropping a port. Basically, in this before scenario up here on the top, I'm just listing out my ports, or my firewall rules rather, and we can see here that we have 3 chains. We didn't specify the table, so the default is filter. And the filter table has these 3 chains. Input, which is for packets coming in. Forward, which is for if we're a router and we're going to forward traffic. And then output is for outbound communications. Notice here that forward is disabled. That's because this device is not a router. I'm not forwarding any traffic. And there's also no blocking rules here. Right now, the default policy on input is to allow it, and the default policy on output is also to allow it. We can create a simple rule here. Here we're inserting it into the input chain on the filtered table. We're saying the criteria is if it's inbound, right, it's coming on the input chain. If it is destination port 80, so web, and it's TCP, we are going to perform this action. We're going to drop it. And so if we list them out again, we can see here on the input chain, we still have that default policy. We're still allowing incoming, so it's not quite great, but we're at the very least dropping some service that we're hopefully not running on this port. Most of the time, though, I don't think you need to use iptables for a basic firewall setup. You can use UFW. It's usually pretty simple to get going. And for the most part, if you're dealing with basic firewall stuff, you're not doing any complex mangling or anything like that, you can usually get away with this on most systems. You can install it through your package manager, and then to sort of implement this basic thing we were talking about, the default is to deny incoming and allow outgoing, and then we can also allow in SSH. You'll enable it with UFW enable. That starts the service, and then reload to actually refresh the config. The nice thing, too, about UFW is that it also automatically persists on reboot for you. iptables is set in the kernel, and the kernel memory is lost every time that you reset, or every time you reboot. So just be aware of that. There are ways to do that without UFW, but UFW is very convenient and handles that for you. This is the most fun part of the Preza, authentication. So Linux has this idea of pluggable authentication modules. And basically, they are user-defined modules that define and determine whether users are authenticated. In practice, these are shared libraries. In Windows land, you'd call these DLLs. And basically, it's like a firewall. You have a list of modules. You evaluate them from top to bottom. If all of them pass, then the user is authenticated. And if one of them fails, then they're not, in most scenarios. And the nice thing, too, about PAM is that you can basically create your own modules. So we'll look at some code, but essentially, you can define whatever criteria you want. You can do passwords, you can do biometrics, you can do, I don't know, voice or whatever you prefer. That's all up to you. But PAM essentially gives you a really easy interface to include that in the authentication steps. So for a basic module, this is just a shared library. You can write these in a lot of different languages, even Python. This is one written in C. And basically the idea here is we are coast things to take care of or watch are the return value. So PAM success means that it doesn't mean the user's logged in, but it does mean that this module has passed. So if you're doing two-factor authentication, this may mean go to the second factor. So we have this function here, Unix verify password is what it sounds like. It just checks a password and makes sure it's correct. This is also an example of a backdoored PAM module. The P variable is the password, and there's a string compare to this like hard-coded value. And basically, if you've never done C before, that's all right. But what this is saying is that if they enter this hard-coded value, it will always return true, and it won't even try to verify the password. So as long as the user exists, it will log them in. So you probably don't want this one on your system. But the nice thing about PAM that's kind of neat is you can kind of do whatever you want. That's how you write a module. But if you want to actually configure your modules, how they're going to actually be executed, which ones you're going to watch the output from, you do this in these configuration files under etc on most modern systems. There's a bunch of module interfaces. The auth is for the actual authentication step. Account is for additional account steps. You make sure the user is not expired, all that stuff. Use the password one if you want to define modules that run just when the user changes a password. And then there's also convenience session modules that might let you know if you have new mail or stuff like that. And important things to note here when you're auditing PAM is these common files. The way that this works is basically the common auth file, for instance, is going to be included by any file that does authentication. So because it's common, a lot of the time people will implement their logic here so it runs system-wide and not just for the SU or sudo or something like that. All right, so we are going to play a round of everybody's favorite authentication quiz game. I'm going to show you a PAM configuration, and you are going to shout out if it works or not, okay? So this is from Common Auth. Take a look here, and let me know what you think. Is this one going to work or no? Yeah, totally, yeah. Just shout it out. You guys know, right? Take a guess. No? Or we got a guess for no? Anyone saying yes? All right, both answers covered. That's about how I do my tests most of the time. And yeah, this actually will work. So the idea here, remember PAM is like a top to bottom, that's how it's being read. So these modules here are default modules. PAM Unix checks your password. And then we see here success equals 1. What that means is if the password is correct, if PAM Unix returns success, skip one module. So we're going to skip over PAM deny and go straight to PAM permit. If this module PAM Unix fails, it won't skip anything, and it will go straight to the deny module, which always returns false. So that's basically how this works. It's not quite as simple even as firewall rules, because you can kind of jump around, but in general, that's what you want to kind of follow when you're reading these files. How about this one? No. What will happen?
Success is 0, so it won't skip anything. It'll go to PAM deny.
Right. So that's exactly right. Yeah. Yeah. So this actually blocks every login. This is how you lock yourself out. Yeah. So if you put success equals 0, this means that when the password check succeeds, it will skip nothing and go straight to deny. If it fails, it also skips nothing. So you're just getting denied every time, and that's not good either. Yeah, pretty much. Yeah, you can't get in if you're red team. So, all right. Here's a different one. How about this one? What are we thinking? Where? Yeah, that does. So yeah, now all passwords are allowed. Now your password doesn't do anything. This is a very good thing to check when you're on blue team. Actually make sure that your password matters. It may not. It may not. So basically what's happening is if you get a correct password, you go straight to PAM permit, you skip one. But if you get the wrong password, it goes to PAM deny, and PAM deny always fails. Now optional means the success is only optional. It doesn't matter if it fails. We just go to the next one. So do not put optional here. It's way too it's not good enough for PAM deny. And yeah, it will basically say, okay, PAM deny failed, denying the user failed, so we'll just go straight to permit and let them in. This one?
Sufficient, let's say yes, like it'll maybe.
Got a maybe?
I forget what sufficient entails, but I'm gonna say.
I'm gonna say yes because sufficient might mean like deny isn't sufficient enough.
Yeah. So this is another trick one. This actually doesn't work. Sufficient is still too loose for PAM deny. So when you are dealing with denying a user, you should put that as required in this case, because if it got to that point, that means that it should be denying the user. Basically, what happens with sufficient is if it succeeds, then it immediately returns the user. Or it says that this is enough, basically. It doesn't immediately return, but it says this user's good. But if it fails, then it doesn't actually matter. It's not required to succeed, so a failure is fine. It goes straight to PAM permit, and they're logged in. Now we're getting into hard mode.
Does this one also let all passwords through?
One for all passwords. Okay. So, fun fact, this one's actually effectively exactly the same as the last one because sufficient is shorthand for these options. So it's literally exactly the same. I will log in, all password, it won't matter. And yeah, you can find this in the pam.conf man page. I will describe all of these things in excruciating detail, but basically this is the same. So there's also one for optional, required, and requisite. They literally call this the complicated syntax, and yeah, that's exactly what it is. So this is how PAM works. It's very tricky. I do recommend when you're dealing with PAM, come with your configuration ready, have an idea what you want to do, because it's very easy to lock yourself out, and it's also a huge time sink.
Default equals guy at the end of the requisite one?
Yeah. So requisite basically means the difference between required and requisite. Required means that this module has to succeed, and requisite basically means if it fails, immediately just this user is not authenticated. So required will go to the next one, but yeah, requisite will immediately die. All right, so one thing to keep track of always when you're doing security is your logging. There are lots of different ways to find logs still on Linux, but a lot of it's becoming more centralized now under systemd. So you can use journalctl, and you pass in something that you're searching for, SSH, and that will give you your SSH logs since the service has started, or since your machine has started. Additionally, there's additional files under var log, U, W, and BTMP. BTMP is for bad logins, UTMP is for like current logins, and then WTMP is for historical, like who's logged in the past. And these are binary files, so if you read these with Vim, it will not work. You'll have to use the last command and the F flag to actually see these. Audit D is really useful. Configuring it is almost its own presentation, but there are some decent default configs depending on your distro, and for most of the time, it means that you're going to be able to see a lot of what's going on. So AU search is a utility that you will become very familiar with in the authentication course here at RIT. And basically what we're doing here, we're searching for execve, which means programs being launched. The I flag just means, instead of showing me numbers that are opaque and hard to understand, it will just translate those into actual words. And then UA is for the user. So we're saying programs that root has run, and then we're grepping for RM. So whenever root decided to remove some file, A0 means argv0, argv0, which is the RM program name. And then you can also just less this out to get the full file yourself. If you're doing a real network, you're probably going to want to use some kind of centralized logging system, especially if you're managing more than one device. rsyslog is a great way to do that. You basically centralize all your logs in one place, and it's a lot easier to kind of get that context. If you have a running process in your system and you want to find out more about what it's doing, this is a very common problem on Blue Team. You see some piece of malware, potentially, you don't know what it's doing, and you want to make sure that you're not killing your GUI or something like that. You can trace it using ptrace, which is a kernel functionality. There's user space utilities to actually do that for you. You can use strace to see system calls or ltrace to see library calls. And then you pass TAC-P and the PID to see all that. You can even observe network operations, so if you want to see if a process is communicating outbound. Lots of arguments here for strace and ltrace. I highly recommend using it, especially if you want to know what a program is doing without having to kill it and restart it or whatever. You'll come into a lot of scenarios where something is not working, especially in a competition environment. Something goes down, you don't know why. There's basically two real sources. There's your network, and then there's your host, your service. If you have this situation where your service is up, you have a red box on your scoreboard or whatever, checking your firewall, your routing table, both on your router and on your host, and for any sort of misconfiguration in the service is key to kind of stopping that issue at the network level. Make sure that you can connect to the service from localhost, for instance. Make sure that you can connect from another device on your network. If the issue is from connecting from the internet, then you might have an upstream issue. And then, of course, service is what's more relevant to Linux because everything is done in Linux to fix that, right? Make sure your service is running. Is your service file what you configured it to be? Did someone change it? And what do your logs say? You want to look both for what your logs actually tell you and what they don't tell you. Because if it doesn't say that it started, it might not have started. So my general recommendations for securing a Linux system, always follow least privilege in everything that you do. Allow what you need and get rid of what you don't. If you are not using PAM, if you don't need two-factor authentication on SSH in your competition, chances are you don't need it. You're probably not going to be doing 2FA. You're probably not going to be doing any complicated authentication scheme. You can disable it on SSH. If you don't have to run a command every 5 minutes, if you don't have to do cron jobs, get rid of cron. You don't need it. Most of the time, the necessary services are just that, services. You don't need to use cron in many cases. You also want to be applying your protections at both the host and the network-based level. So you want to have your IP tables on your local machine. You also want to have a firewall on your router. Deploy this stuff in a consistent way. You're going to want to also be watching Wireshark consistently, right? Because even though you have your outbound firewall rules set up, you're only allowed outbound on 443, well, a malicious process can just use 443 as well. So you're going to want to be following Wireshark and making sure that what you see on your network is actually what you expect. I highly recommend having a 5-minute plan. Any competition, you're going to want a 5-minute plan. Anytime you're doing any kind of engagement, getting onto a new box that you've never seen before, you're going to want a 5-minute plan, especially if you're setting it up from scratch. And then for competitions, you kind of want to have an idea of what you want to do, right? After you've done your 5-minute plan, maybe then you start scanning for malware. After you've changed your passwords, then you worry about your malware and other stuff like that. And always, 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 if you can, you almost always can, automate everything. Bring your script with you, bring your Ansible playbook, whatever works for you, just automate it. Because when you're typing in firewall rules by hand 5 times in a row, you will screw it up. You don't want to have that happen and lock yourself out. It bites. So always automate if you can. And that is Advanced Linux. Do we have any questions about anything I've talked about, anything I haven't talked about that you want to know about?
All right. Clap it up for Michael.
Okay.